and welcome back to my YouTube channel. So in this video I'm going to be showing you how to estimate the ideal sample size when you do not know the size of the universe or when you do not know the size of the population. This is generally used when you have a rough estimate of the percentage of prevalence of a particular problem or a particular characteristics in a population, but you do not know the size of the universe of the population. So for example, let's say I'm going to do a study on the prevalence of work-related stress among IT professionals in a city. However, I do not know the size of the population, that is, I do not know how many IT professionals are there in the city. Nevertheless, I have examined previous literature or existing literature, and it tells me that the prevalence might be around 7%. So around 7% of IT professionals might be experiencing work-related stress is what the existing literature says. So let's assume that. Now based on this data, the 7% prevalence, I will be using the formula and I will calculate the ideal sample size that I need to select for this particular study, right? Now I have already done an example over here. Here I am assuming that the prevalence is around 1%. That's why it's 0.01 over here, you can see. Based on that, I apply the formula and I've calculated the ideal sample size for my study to be 15. Okay. Let me go back to the table and the formula here. So this is the formula: n is equal to z square into p, 1 minus p divided by d square. So basically here each of these values are as follows: z is equal to 1.96, which means 95% confidence level, and 5% margin of error, which is represented by d is equal to 0.05. Now when I just substitute these values, and of course p is the the percentage of prevalence of a problem. So if I say 7%, then p here will be 7. In this case, in the example that I showed you, I have used 1% as the prevalence, so I have put it as 0.01. Now what do you do after this? Once you calculate the ideal sample size, there is always a percentage of people who may not respond to your questionnaire or who may not be willing to be part of the study. So there we calculate the percentage of non-response. So this percentage of non-response is nothing but the percentage of people who are not going to respond, who are probably not going to respond to your survey or questionnaire, and there's a formula for that, which is n divided by 1 minus r. N is of course the calculated sample size that you've already calculated, and r basically represents the expected non-response rate, right? So let's say if you're expecting around 20% people to not respond to your questionnaire or interview, then r is equal to 0.20. If it is 10, then it should be 0.10. So based on that, again you recalculate the sample size, right? So this is not a necessary step, but it is highly recommended because not all questionnaires and interviews are always answered. So based on existing literature or understanding the ground realities, you can decide whether you should go for 10% non-response or 20%. Higher than 20% is rare, but still possible though. So this is a very useful table. Instead of doing all these calculations, you can just refer to this. I just want to say that this is not my formula. This formula is by Daniel and the citation is provided here. I have just created this table so that it's easy for people to directly refer to the ideal sample size that they should select based on the percentage of prevalence, right? So if you did like this video, please give it a thumbs up and subscribe to my channel for more such videos. Thanks for now.